Good afternoon, good morning, or good evening, wherever you are. Welcome to CodeLive. Today we're going to be talking about building an external dashboard. So a dashboard that is developed, lives off of the Salesforce platform, that still subscribes and consumes Salesforce data. We're going to talk about what our problem that we're trying to solve is. We're going to talk about how we code this problem, and we're going to start off with some introductions. So with that said, let's do those introductions. On the stream today with me is Kevin O'Hara. You want to say hi, Kevin?
Hi, everybody.
And I asked Kevin for a fun fact about himself, and he said when he was in college and young, he had a nightclub DJ role. So Kevin, if you were going to be a DJ today in the Salesforce ecosystem, what would your DJ name be?
It would probably have to be Refactor because I'm constantly changing everything I do, including
Refactor. All right. I think I was going to be one. It would be probably DJ Cody Codes. I think that sounds nice and fun. Cody Codes.
That sounds great.
So Kevin is the CTO at a super secret company, and I'm a developer evangelist here at Salesforce. We're looking forward to getting into this, so let's just sort of dive right into things. Did you know that Lightning Web Components is open source? That means if you go to lwc.dev, it's a URL, you can learn all about how to spin up projects with Lightning Web Components that are external to Salesforce that you can host in on your own hardware anywhere you'd like. And we're going to build one of those apps today with Lightning Web Components OSS. And we're going to use this dashboard to pull Salesforce data and to react to Salesforce data as it changes. We're going to do that with the change data capture events from Salesforce. We're going to show some pretty graphs. So we're going to, whenever an event happens, you're going to see something react in our dashboard, nice, pretty graphs. And we're going to show how we can interact with other things in the JavaScript development environment. So we're going to be dealing with some NPM modules. We'll be pulling in one for Chart Jas and one for Lightning, the Salesforce Lightning design system. And so that's kind of what we're going to be working on today. And we've already built some of this because we want to focus on building with Lightning Web Components. So some of the stuff that we've already built is a basic Node or Express app. And we've done this using a tool called Create LWC app. This is an NPM module you can install. You can use npx to run Create LWC app. It's going to ask you a few questions, spit out a bit of template or bootstrap code for you, and you'll have a basic Node Express app that is using Lightning Web Components open source. So we're going to start there. We've also done a little bit of wiring up with JSForce, which is a JavaScript library to access Salesforce data. And we've set up our code to subscribe to the change data event. So you'll see what that looks like here. That's all sort of the stuff we just need to get started with what we're doing today. So today we're going to be writing in some new Lightning Web Components. We're going to use a thing called Socket.io to forward our streaming data to the client, and we're going to give our app some good looks. We're going to give it a header, we're going to put some cards in, and we're going to create those new components. We're working with this project. After the stream, we're going to upload our code as is to this URL. If you want to go to github.com/sfcodelive, you'll find that we are the external dash with LWC OSS repository today, and I encourage you to check that out afterwards. So with that said, let's get into the code. And you'll see here that we've done a little bit of work, and I've got on the right my my JavaScript, my Express node server, and the index.js, which is the basics of our node server. And on the left here, I've got the actual LWC OSS app. One of the things that the Create LWC app gives you is the ability to run a command, npm run watch. And as we spin this up, we'll be able to reload a page. And here's our basic app. This is what we get from the boilerplate code. But one of the nice things about it is I can dive into this and I can edit this. So let me just get rid of this bit and that bit. And I'll just say, hello, CodeLive. And as soon as I save this, it's going to automatically refresh the page and show us the changes we made, which is super cool, super fast. So with that said, Kevin, do you want to talk us through a little bit about what we've done in the index stuff to set up Socket.io?
Yeah, sure. So we'll just kind of start at the top. So we're using Express, which is a web framework for Node, and Socket.io, which is a WebSocket library that plugs nicely into Express, and then JSForce to kind of talk to Salesforce as kind of our back end. So really some stuff up here towards the top. You've got the port that we're going to be listening on. So the Lightning Web Components framework, the front end, is going to be listening on port 3001, and our backend server is going to be on port 3002. Got a couple of things here. The channel that we're going to be listening on, we're actually going to be listening on, this is fairly new in the streaming API and eventing in general in Salesforce, but we're going to be listening on the change data capture events. So I think we've set up counts, contacts, leads, and cases for change data capture events. So we're going to basically be taking any of those events and building them up through our server up to our Lightning Web Components app. There's just a couple basic things we need to connect to Salesforce. These are all in a .m file in the root of the project, but we need a Salesforce username, password, token, and a login URL. So it checks for those things. Here, this is where we construct the JSForce connection. So this is how we talk to Salesforce. And then we run the login process here. Once we're logged in, we create a streaming connection to that channel. So all those change data capture events are going to be captured in the streaming channel. And then we're using Socket.io to emit an event up through our application with the event type of CDC.
So Kevin, if we're subscribed to the events, the CDC events here in our server, why do we have to re-emit them with Socket.io?
Well, we actually could do it client side. We could actually do all of the streaming in the browser. It was just a little bit easier to kind of set this up here. The reason why we have to kind of re-emit those is just because we're capturing the events on the server side, and then we're just kind of essentially re-emitting them through the Socket.io connection in our Express app. But this could be done all client side if you wanted to.
But if we did it client side, we'd have to expose those credentials to the client, right? So we'd be leaking credentials.
Yeah, you would have to. There's probably some secure ways to do that, but it's just a little bit cleaner to keep it on the back end for now.
Yeah, I like this. It also means that wherever our server is running, it's only going to make one connection to Salesforce, and we only have one CDC client, but we're sort of rebroadcasting this to any front end that is loaded our dashboard. So I like the way that works. That's pretty slick.
Yeah. Yep. So then we have kind of towards the bottom here, we just have like some logging. So when Socket.io connects, when there's a new connection that comes in, so a new client, so our Lightning Web Components app would be a client. Once that connects, it will drop a console log here. What's actually cool about the way that we're doing this live share is that we're able to, through VS Code live share both of the ports. So we're actually connecting through Kevin Poorman's machine. He's exposed port 3001, 3002, but I'm remote in another state, and I'm able to actually to connect to those exact same ports because they're proxied through the live share. So you'll see both of our clients connecting and disconnecting as we're kind of updating things. The last line here at the bottom is this is just basically launching the Express app.
So that's sort of the basics of, okay, now we've got an Express app, we can actually launch it. We've seen that we can do the live, the sort of watched updates. As soon as you save a file, it reloads the browser. How do we actually start going about and pulling in to
install those?
And then we'll do install, and then I like let's do the SLDS. That's a mouthful. And you see that I've got this set up here, and I'm adding this -- save flag at the end down here in the terminal. And that save is going to actually write it back as a dependency to my package.json file. So let me run this. And that'll take just a second. And while that's running, I'm going to set up so that we can serve our CSS and icons, etc. Got a command here to run to do that while after that's installing. So let me run this real quick. Just going to move some files in place. All right, so now we can we can actually use the Salesforce Lightning Design System. What I've done is I've installed that node module, and then I've created a folder here called the SLDS folder that has everything we need in it. So that's what I did. I moved some of those information into the resources folder from the node where the node module installs. To install the SLDS, we have to do a little bit of work around how we inherit properties and CSS from various things. So when we pull open a Lightning Web Component, I'm going to pull open the app.js folder here. You can see that I've got a pretty basic boilerplate Lightning Web Component. I've got export default class app, and it's extending this Lightning element. And Lightning element is something we provide in the Lightning Web Components framework. But if we want to pull in the SLDS, we've got to actually do that in a way that we can inherit from a component that is setting those up. So let's go ahead and create that component. And what I'm going to do is I'm going to open a folder here, and I'm going to call that folder Lightning Web Component, Lightning element with SLDS. And inside that, I'm going to create an actual file, and we'll call this Lightning element with SLDS.js. Right, and so here's I got my new component, and I've got the JavaScript for it. And what I'm going to do is I'm going to put in some prepared code so that we can use this here. Let me paste this in. And what I've done is I've set this up so that we're going to import Lightning element from LWC, but then I'm going to turn around and extend it with my class here. So I've got Lightning element SLDS extends Lightning element. And it occurs to me here that I've made a little bit of a typo. So let me fix that in my folder here, my name, SLDS. All right, and now that I've got this set up and I'm pulling this in, I can go back to my app.js and I can actually have it extend Lightning element with SLDS if I can type it. Okay, now this is going to give me an error. Visual Studio Code is going to say it's not defined. So what we can do here is we can come up here to our import area and do another import. With SLDS. And we're going to do from, and I'm going to go up a directory, up another one, and then we'll do Lightning element with SLDS, Lightning.js. Okay, now if we run our server, you'll notice that this one is saying it's not actually using Lightning elements. We can get rid of this line. And because we're extending Lightning element, if we rerun our watch server,
You may need to remove the brackets around the Lightning element with SLDS because it's the default export in that file, I think.
Ah, good call. So we can just get rid of those. And it's going to come back and say, cannot resolve this. Or did it? It seems to have resolved. There we go. Now, if we go into our app.html, we can actually put in like a little bit of a template. So if we wanted to put in a template for like a header, we can do that. Now, rather than type all that out, I've got a little bit of a copy and paste job that I'm going to do here. And I'm going to get rid of this greeting, and I'm going to get rid of the icon, the LWC icon, and I'm going to put in my template there. That. Oh, looks like it's still failing. Can't resolve. So if we're going to go backwards from our Lightning element with SLDS, did I spell everything right?
I think there's the duplicate. I got it. I think there's something duplicated in there.
Oh.
See if that fixes it. There's an unexpected token, exclamation point.
You getting an unexpected token?
Yeah.
Lightning element with SLDS.
Hmm.
And we are in app my. I put it in the wrong folder. It's only 2 directories up. Or is it? This is how you know it's a live event. So we've got, down here, we've got our My App modules. So we're up 1 from app.
I think it's only.
I think it's only 1 up. Yeah. Interesting.
You could restart the watcher too.
Yeah, it could be that. That seems to, oh, no, there we go. I think it's 2, so I'm gonna put that back in there. No, it is only 1. Let me move the folder and see if that helps.
It might, just because.
So I moved it to the modules folder. I don't think there's a way to show that on the stream, but I did move that. So here we go, modules there. So this is trying to load modules, my app. So we should be just modules. Oh, didn't we put this in a lib folder?
Yeah, I put it under
Client.
Source client lib.
Yep, that's probably
Maybe something special about the modules folder when it contains the
yeah.
Lighting Web Components. So
we'll put this underneath here. So we'll do change this to lib and get rid of, don't need that. And here in the lib, we'll just move it. Get rid of that there directory.
Working for me now.
Yeah, there we go. Now we've got our header, and we figured out how to start doing a little bit of debugging here. So what we did is we ended up creating our class that we're going to inherit from in the lib folder and loading it this way. Now, if we go into our app, you can see that we're loading this element with SLDS, and we're using the SLDS stylings here in our template. So we've got a nice little header there, but we're missing our icons. What happened to our icons? I think it's that we changed the directory.
Yeah, it's looking at resources assets / I think it should be resources assets SLDS.
There's no assets folder.
Oh, it's resources SLDS assets.
Assets. There we go. Okay, and we got this hello CodeLive bit down here. We don't really need that or this link, so we're just gonna get rid of this bit. And here now we only have our header. So we got a good start to it. Let's go ahead and create our first component. Now, is our first component going to be the chart, or do we need to set up socket.io for the client?
Why don't we connect socket.io up first?
Okay.
Yeah.
You want to lead the way on that one?
Sure. Okay, so Should be on the right screen here. Okay, so there's a couple things we needed to do with socket IO. First, we basically need to import the library, and then we need to open up the socket connection and kind of listen on that. So there's going to be a couple things that we want to do here. We're going to need to import some things from Lighting Web Components. So we need the track annotation. And I think we're going to track a couple things. So one is we're going to have a single socket connection. We'll track that. And then we need to track whether the socket's ready or not. Because I think what we'll do is we'll wait for the socket initialization happens kind of asynchronously. So we're going to want to wait for that socket to open before we try to render any charts. So having a variable here will help us. So let's do socket ready.
I like the way you're thinking about keeping everything asynchronous.
Yep. So so we've got two properties: the socket, the actual socket connection, socket ready. Okay. Let's see. I feel like we have like two prettier configs that are conflicting because it keeps changing.
Yeah. We'll make it pretty before we push it to the Git repository.
Okay. Maybe we'll maybe move this back to 4. I think that'll fix it. Let me go back to. Okay. Okay. So what we'll do is like we'll listen on some of the lifecycle hooks. So do the connected callback.
And this is a generic callback built into the website, the web component standard. That's not specific to LWC.
Right. Yep. And then we want to clean up too. So like when the component is disconnected, we want to make sure we close the socket connection. So. And then what we'll do is I don't like to have a bunch of stuff into these lifecycle components, like to create smaller functions. So we'll have one called open socket. And then this, our formatters are fighting a lot. Not sure exactly why.
It's okay. We'll make it pretty when we push it to the Git repository for everyone.
Okay. All right. So actually, I think we need to make this an async function because we're gonna basically kind of on the fly require the socket IO library.
Now, why would you do that instead of just importing it up at the top?
Because if you do that, then every single time your application loads, whether this component is mounted somewhere or not, it's going to require those files. So this keeps the client a lot lighter. So if you're basically requiring things on demand, you get less. It's just a lighter weighted application. So it's kind of a good practice to require things as needed.
Makes sense.
So since it's async, we'll do await require socket.io-client. Just save that, make sure it's working. Seems to be working. Okay. And then we said our socket was on port 3002. So let's create a socket instance. So we'll say like this socket equals IO 0.0.0.03002. And then what you need to do in socket IO is you need to listen on some events. So the first thing we're gonna do is we'll do this .on connected, and we'll provide a callback.
Do we want this socket on connected?
Oh yeah, correct.
I like the use of arrow functions there.
Yeah, it's nice because then we can call this dot socket ready. We don't have to worry about this becoming something else.
Mm-hmm.
So dot socket. And then we'll just do this. We'll see, you should see in the console. Oh wait, I didn't actually call the function yet.
Oh, nice catch. I was like, where is it? Why is it not there in the console?
Okay.
Yep, and now if you look here in the terminal for our thing, you'll see that 3 clients have connected. And it's because there are 3 viewers of the web app. I've got one, Kevin has one, and we've got one for our display screen that we're showing you. So all 3 of those clients connected when we saved that file. It was pretty cool.
Yeah. Not sure why we're not getting the console log in the window though, but.
It is interesting.
But we are seeing the connections.
Yeah. You see the library loading. Interesting.
Okay. Well, we should see.
It's probably a quirk of the way we've got live share set up.
Oh, you know what? I'm actually listening to the wrong event. It's connect. That's why.
Oh, there we go. Socket connected.
Okay, cool. Okay, so then if we remember back from the server file, so we were emitting on the socket connections CDC events. So we'll want to set up like we actually don't need to do it in this file, but if we wanted to like create like a tracker and track how many CDC events we're getting, we could do that here. But I think this is pretty much what we need to do. And that, I mentioned cleanup's always a good thing. So I'll do this at close socket. I'll have to write that function. This doesn't need to be async. And then I think we just call, do this dot socket dot close, which will close the connection. In case we were building an application where like this component was, you know, placed into the DOM and then removed later, this would make sure that we close that connection, don't leave it open, which could cause memory issues. And we'll just, we'll actually null out. And we'll say this dot socket ready equals false. So now everything's kind of neat and tidy. So I think now we're ready to build a chart component. And what we'll do is we can actually take this socket connection and pass it down to the charts themselves, and they can listen on those events and decide how to handle them.
And how do we do that? How do we pass it down?
So we can do that via a property on the chart component. So do you want to go ahead and start building the chart component now?
Yeah, so under my app, here we've got, we'll go into the app subfolder, excuse me, the my subfolder, and we'll create a new folder called chart. Or do we want to call it something else? It's just chart, right?
Sure.
Sure, all right. And then in here we can create the standard files. So we'll do new file, chart.js, and we'll do another one for the HTML. And we'll do another, do we need CSS for this one? I forget. I think we do.
We might.
It
doesn't hurt to have one. You can have it.
Yeah, exactly. Okay, so now we've got 3 files opened up for our chart.js. And the first thing we do for any Lightning component is import parts of the LWC library, right?
Yep.
So import, we're going to need probably API and track. So API gives us the ability to pass things in. And track makes our properties reactive. So So we've got those. Now we get the little squiggly lines here because we're not using them yet. Don't worry about that. Those will go away here in a little bit. Is there anything else we need to import? I think we need to import our Lightning Web Components SLDS here, the same way we did in the app.js. So I'm just going to copy and paste. And I'm going to save that, make sure everything's loading okay. Good job. All right. And then how do we actually go about building out a chart component? Are we going to use a library or?
Yeah, we'll use Chart Jas. It's
okay.
Probably the easiest one to use. We found there's actually some examples out there, Lightning Web Components examples using Chart Jas, which is pretty cool.
Now, is that another NPM import? Do we have to import something?
Yeah, we need to install chart.js.
So let me cancel my little server that's going here, and I'll do npm install chart.js.
Yep.
And then I'll do save again. That puts it in our package.json file. There we go. Keep going. You can do it. There we go. Now I'm going to rerun my server here so we can launch this and see things going in real time. All right, so we've got this. Let's go ahead and create our class. So we'll export default class, and we'll call this chart. And we'll have it extend lightning element with SLDS. Okay. So how do we go about building a chart? You're the visualization guru here. Where should we start with this?
Well, I like to think about first like the API that we want for this chart. So I think it'd be cool to be able to configure it with what type of S object we want to listen to. So remember, like that change data capture stream, we're listening to there's going to be a bunch of events coming. So anytime a lead, contact, account, or case changes, we're going to get an event. So what I thought would be cool would be to configure this with an S object and then let the chart filter those events and then do some counters on what fields are being updated. So if we want to start with the API, we could add some API properties here. So we'll need like a.
Now by doing this with the API property, we can pass in information, and that allows us to create a reusable component. So we can use the same component but pass in, account or case or contact, etc. Yep,
exactly. And then the other thing we'll need in the API is, remember we said we're going to pass down that socket connection. Mm-hmm. So we'll do API socket.
Oh, and so we're just going to pass that in here. Okay, I like it.
Yep. We could do it probably all through eventing too, but this is one way of doing it, is just kind of passing down the connection and letting the component listen on whatever it wants to listen on. Okay. And then maybe one last thing is do an API for chart type. So maybe we want to reconfigure the type of the chart on the fly, and we'll default it to donut, which is a popular one for Chart.js.
I like donuts. Donuts are tasty.
Who doesn't, right? Okay, and then let's create a couple things that we want to track that'll help us with the rendering of the components. So we'll do let's track the number of events that we're listening to.
So there's going to be the total number of events that have occurred since we loaded the page or loaded the component. Okay.
Yep. Yeah, we can display that maybe with the chart, just how many total events we've listened to, and then a couple things we want to when we get the socket as part of the API, we're going to want to initialize that and listen on the events that we need to listen to. And so we'll want to track that, whether we've initialized that, and then we'll want to track whether we've built the chart or not. It'll just kind of help us as we're going through the life cycle of this chart and updating it with data, just to kind of know that the socket connection is good and then the chart has already been initialized. So we'll do track. We're going to default these all to false.
I like how you also put an initial events equals 0.
Yep. Okay. We've got some properties. So one of the things that we'll probably want to do is we'll probably want to listen to initialize the socket. We'll probably want to listen to the rendered event, just because there could be some timing issues if we're trying to initialize the socket with the connected callback, because it may not actually yet be fully initialized. So what I want to do is check a couple things like when the component renders to see if we're ready to initialize the socket connection. So we'll do that with the rendered callback.
So rather than the connected callback, we're going to use the rendered callback so that when our component is rendered, not when it's dropped on the DOM, not when it's connected, this will execute.
Correct. Yeah. So let's. I'm first going to build a couple. I think I'll build a couple functions to initialize the socket connection. So I'll do initialize socket. This as a function here, and we'll do. Put like a log statement in here. Say init socket. So now is where we need to listen to those events. So we're going to assume that we'll check for the existence of the socket somewhere else, but we'll do. So here we'll kind of know that we already have the socket. We'll say this dot socket. Oops. And our event is called CDC.
We're very creative with our names.
I think what we'll do is we'll create an on message function in this class.
Okay. As you say, we're going to have to bind this to it so we can pass our variable scope.
Why don't we just add this? Just add this function here so we can make sure this compiles. We've got kind of a callback now.
I think we're also going to want to put this dot socket initialized is equal to true here.
Oh, good call. Yep. Then that'll help us track that. Why is this?
Let's see what that says. It's expecting a semicolon. Is it? It's because it extends, isn't it?
Oh yeah, there we go.
There we go.
Oh look, everything just magically works.
Magic. You spell the keyword right and things just happen to work.
Oh, okay, cool. So so that's how we'll initialize our socket. And then the other thing we'll want to do is we'll probably want to.
We've got that chart initialized one, so we should probably take care of that.
Yep. So we'll do. So we'll say initialize chart. Init chart. And this is where I think we're going to want to load chart.js. So I think we're going to need to make this an asynchronous function so we can await on that. So we can say await.
Now, Socket.io has a special client version versus a server version. So when we loaded Socket.io, we loaded socket.io-client. This Chart.js is just Chart.js. There's no client version.
Correct. Yeah. 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 And I think the purpose of Socket.io having their own separate client version is just so you don't have to import the entire bundle, which includes both client side and the server side into a web app. You really just want the client piece.
Yeah. Okay.
So okay, cool. So so I think now the rest of what we can do is we can let's hook up this rendered callback.
Now, rendered callback is one of the standard lifecycle components of web components in general, not just Lightning Web Components.
Yep. So I think first we want to check this. We want to check a couple things. We want to see if we have that socket object, and then whether or not it's been initialized. And if we have the socket object, but it has not been initialized, we'll call initialize on that. So if not this dot initialized. So if the socket has not been initialized, but we do have a socket passed down through the API, we'll call this dot. And then what we'll do, I think for the initialized chart, we have this chart initialized. So we're going to have to do some setup of the chart. We might have to work on the template first, but we'll do, at the end of this, we'll do this.chart initialize equals true. And then we're basically going to do the same thing here. We'll say, I'm just going to copy and paste this.
Now this is it's calling an asynchronous version, so we need to mark this one as async as well.
Okay, right, yeah. So right now, I think what we should do is we should check whether the chart's initialized and the chart's not initialized and the socket is initialized. So basically this is saying if like the socket's ready, but we haven't initialized the chart, then we'll initialize the chart.
And do we need to mark that one as a wait?
Yes.
Okay.
Just to be safe. It'd probably work without it, but we'll just be safe.
Better safe than sorry.
Yeah, exactly. So it's not that useful yet without a template. Should we jump over to the chart template and start getting that kind of hooked up?
Look at the chart template here. So this is blank, as obviously. The first thing we have to do is do template. All right, so now we've got a basic template that we can use. In order to save some time, how about do we have an example HTML template that we can put in here? I think we do. Let me put that in here. There we go. It's really simple, but we've got a class called chart, and then we've got this canvas element. Why are we using a canvas element?
That's how Chart.js renders its charts. So it just requires a canvas element on the page, and it draws the chart inside of that element.
Okay. All right. Now we're doing this LWC:DOM equals manual. Is that because we're going to let Chart.js draw things in the DOM for us, or because normally that's not allowed?
Right. Yeah. Exactly. It's basically telling Lightning Web Components just ignore that element and just let whatever happens in there happen.
Okay. Okay. And then we've got this events here that we're going to put. This is our event counter.
Yeah. Just give us a quick count on how many events are processed.
Okay. So that's our template here. What else do we need to do to actually draw this chart?
I think we actually need to go. We'll probably jump back to the chart.js file and we'll initialize everything in there.
Okay. So this is going to be probably down in our initialize chart method.
Yes.
Okay.
Yep. So let's see what we need to do. So one thing that we'll need to do is, actually one thing we could do right now would be, we could test, if we wanted to, we could test to make sure that we're getting messages through this component. We could basically add a chart to our app.
Mm-hmm.
And then do you want to test and make sure we've got the connectivity?
Yeah, incremental improvement.
Exactly. So let's go over to the app HTML template.
new file to open. Here we go.
And then I think what we could do is, why don't we put one of these, well, there's a couple things we did in our app.js file. We've got a, remember we have that socket ready variable. So what we could do is when that socket ready flips to true, we could render our charts.
Okay.
So maybe we could do like a, an if portion of, like a templated if portion.
I can type. Yes, template if, right?
Yep. Or if colon true.
Okay.
And then the equals, and then the variable socket ready demo case.
Okay.
And you don't need the quotes.
Oh, okay.
And then why don't we add a chart, one of our new fancy chart components there.
And it's going to be my-chart.
Yep.
Because it's in the underneath the my directory. So my-chart, and then we have some API things we're going to pass in, right?
Yeah. So we can remember we created. Let's see. We created a an S object property that we can pass in. So what should we do?
Case.
Cool. And then we need to pass that socket connection. Socket equals, and then yeah, that's the socket connection from the app class.
It's all running pretty smoothly here. What else do we need to do here?
I think that's it for the chart. I can't think of anything else.
All right. Oh wow! I just saved that, and look, we've got this events 0 here.
Cool.
It shows up in our app, so we're getting the component is rendered. Let's go make a change to a contact here, or we did cases. Did we do cases? Yeah, we did case.
Yeah, that's cases.
All right, let me find a case here real quick, and then we will see what happens when I modify a case. So I'm going to change the priority of this case from high to medium. If I save it, I got a case update here in the.
You know what? I don't think we ever incremented the counter in the chart.js.
That'd probably be useful, wouldn't it?
Yeah. So so right now, well, let's look at a couple of things. So I think we probably want to increment the counter just on events that match that S object type. So because we basically want to filter for this component because it's it's configured with a case S object. Yeah. We probably want to filter that. So so if we're in the chart.js on message, let's add some functionality here. And so I kind of know how these change data events kind of are structured. So we're going to destructure this data here, and we'll kind of pull out the properties we need. So I know that there is a change type, which would be like update, delete, insert, and then there is an entity name, and that is inside of a data.change event header. So let's just log this out. Cool. And then
so let me throw an event here, make our case high priority again. Oh, it just reloaded. Let's try that again. Back to medium we go. All right, so we got the update.
Cool.
That's good.
So I think what we want to do is we want to make sure that right now, if like you were to update a contact, this chart, even though it's configured to, we're configuring it to listen to case events, it's getting all the events, so we want to filter those out. So there's an easy way to do this. What we could do is we could say if entity name. I always liked it when I'm comparing strings. I always like to lowercase everything just to be safe.
Yeah, that's a good tip. Now we're running a little short of time, so while he's typing, I'm going to talk about the two questions we've got that have come in from the community. Somebody wanted to know if socket port 3002 is reserved. Can we use any other port to connect? Now that's getting into the details of the way the create LWC app node NPM module works, and I don't have a solid answer for that one off the top of my head. I suspect you can go in there and change that. I don't know where to go in and change that. It's probably in a combination of the Webpack config and the way the Express server is set up. So we can dive into that in the show notes, but for right now, we're going to go with just port 3002. And the other question that we had come in is, can we use Visual Studio Professional for the same setup too? And again, I'm sorry, I don't have a great answer for that. I am not a Visual Studio Professional user, so I don't know. You can definitely do it with Visual Studio Code though. So that's we've got this set up, and if we you just finished typing that out and you set it so that it will throw the event counter up as well. So let me change my case here. And we'll see it, I got the message received, but I didn't see it actually increment the counter. Events, right? So it should increment that. So we want to show what this chart actually looks like a little bit here. So I'm going to use the magic of television to pull in some pre-written code that we've put together. And we're going to pull this in so that we can see what it looks like when we run our app. Let me just do this. Save that, and then got nothing really showing there, but if we go into this and we change our event again to low, oh wow, lots of errors going on here. Type data.
It's expecting that the chart has been, we need to fill out the rest of the initialized chart.
Ah, okay. So up to our initialized chart here, and we've got some television magic on that one too, I think. Let me see if I can't find it. And do this. Okay, oh, there we go. Now you can see that we have case field updates up here, our events down here. Let me go in and change that event. Let's see, change my case one more time. Oh, hey, look at that. What is that showing us, Kevin?
Yeah, so it was amazing that you wrote that code that fast. So what it's doing is, and this change data capture events, it tells you what fields have been changed. So every single update will give you sort of like an array of the fields that have been changed. And so what we're doing is we're just incrementing a counter in the data for the case. And so if we were to add another chart component and give it, configure it with the S object of account, it would render another component here and do the exact same thing.
So let's actually do that. Let's just throw that in here, and we can say account, or do you want contact?
Whatever, dealer's choice.
We'll do contact. All right, and now since we reloaded it, all of our events got reset to 0. So let me do one on case here. We'll change this to high. And that should draw, oh, there's our case one. Now if I switch over to a contact and I change this contact's title, there we go. Oh, hey, there it drew our contact one. So we've got that one component we wrote to do our chart that we can then reuse. And with that, we're running out of time here, so I'm going to jump back over to our slides here for just a second. Present this again. And today, here's a sort of an overview of what we did. We created a node-based dashboard app. And we used Lighting Web Components OSS to build a reusable modular UI through components. We incorporated Socket.io and Chart Jas, as well as the SLDS from NPM modules directly into our app. And we set up Salesforce to stream notifications to our dashboard whenever a field is changed on, in this case, cases or counts, because those are the two objects. The cases or contexts, those are the two objects we chose to draw. If you want to learn more about this, I want to start you off with the knowledge that Lighting Web Components are open source. You can use them off-platform easily. You can always use it with other JS libraries, like we did with Socket.io and Chart.jas. And you can still surface and use all that data from your Salesforce org. So if you want to know more, you can go to this trail mix that we've put together. And the trail mix has, hold on a second. Slides too quickly. Here's our trailhead, and this will be in the video as well. This trail mix, and it'll walk you through doing all of the bits with Lighting Web Components and more. So look forward to seeing people complete that. If you have questions, you can still reach out to us on social, Salesforce Devs, and we'll be monitoring that here in a little bit. And then with that said, I think we're right at time. So if you get the survey here at the end, please fill it out. Please be as detailed as you feel comfortable with. I promise we read these and we look forward to hearing your feedback. With that, thank you very much for tuning in to CodeLive. Kevin, thank you for joining me today. I think we did a bang-up job of putting together a Lightning Web Component and putting it out on a Node app externally. You can find our application, including the components we wrote, on the GitHub page, and that GitHub URL will also be in the video URL as well. This was recorded, and you'll be able to see the recording of this on the sign-up page for CodeLive, starting probably tomorrow-ish. All right, so with that said, thank you very much for joining. Goodbye.